Continuing on with some problems in 1.2, let's take a look at number 12. We'll look at 12a first of all. We have the equation y equals 200 minus 4x, which represents the number of spaces that a flea market manager can rent if he charges X dollars for a rental space at the flea market. So y equals 200 minus 4x. In part A, we're asked to sketch a graph of this linear function, and we're told parenthetically that the rental charge per space, which is given by X, and the number of spaces, which is given by Y, can't be negative quantities. So that means that X has to be greater than or equal to 0, Y has to be greater than or equal to 0, which means that when we sketch a graph of this thing, we only need to worry about positive quantities for X and Y. So let's just try a couple of values. Maybe we can make a quick table of values here for X and Y. Of course, as X is equal to 0, Y is equal to 200 minus 4 times 0, which is, well, that's just 200. Now let's get some bigger values of X. Let's suppose X is equal to, oh, I don't know, how about 10? Well, then Y is going to be equal to 200 minus 4 times 10. That's 200 minus 40, which is 160. If X is equal to, say, 20, we have 200 minus 4 times 20. That's 200 minus 80. Well, that's going to be 120. And if X is equal to 30, we have 200 minus 4 times 30. 4 times 30 is 120. 200 minus 120 is equal to 80. If X is equal to 40, we have 200 minus 4 times 40. 200 minus 160, which leaves us with 40. And finally, if X is equal to 50, we have 200 minus 4 times 50. 4 times 50 is 200, so you're left with 0. So we can mark off 4, 5 by 10s on our x-axis. And it looks like if we mark off by 40s on our y-axis, 40, 80, 120, 160, 200, we should be able to get a pretty nice graph of the parking spaces dependent upon the amount charged. So if x is equal to 0, y is equal to 200, 10 we're at 160, and so on, 20 at 120, 30 at 80, 40 at 40, and 50 at 0. So we have a nice linear function here. Supposed to be a nice straight line there that represents the graph of this function. Now in part B we're asked what the slope, the y-intercept, and the x-intercept of the graph represent. Well, you can see that let's start with the x-intercept represents, well, if you charge 50 bucks a parking space, you're not going to sell any parking spaces. Or what are we talking about here? Rental spaces. So if you charge $50 a rental space, you're not going to sell any rental spaces. However, if you don't charge anything, well, you're going to have 200 spaces that will fill up. I mean, you know, if x is equal to 0, y is 200. So if you don't charge anything for spaces, you can expect all 200 spaces to fill up, obviously. But if you charge $10, well then, per space, you can expect 160 spaces to fill up. Now we're also asked about the slope. The slope, remember, is the change in y over the change in x. So if we just take maybe the first 2 points here, if we take 200 minus 160 divided by the corresponding change in x, we have to subtract in the same order, 0 minus 10, we see that we get negative 40, so we get positive 40 over negative 10, or a positive 4. Make that a negative 4. Positive over negative is a negative. And you can see that's the coefficient of x here. So that means that every time you increase, since your slope is negative 4, what that means is an increase of $1 in the rental price will result in a decrease of 4 spaces that are rented. So if you increase the rental price by $1, you'll lose 4 spaces. Okay, let's go ahead and take a look at number 18. We have the monthly cost of driving a car depends on the number of miles driven. Our friend Lynn found that in May it cost her $380 to drive 480 miles, and in June it cost $460 to drive 800 miles. Part A, we want to express the monthly cost, C, as some function of D. So we want C, the cost, to be a function of the distance driven, D. And we're going to assume that we have a linear relationship, and that will be a suitable mile for this function. Well, that means we're going to have our cost dependent upon our distance driven. So if you make a little table here of D and C, you can think of D as our independent variable, C as our dependent variable. D is playing the role normally played by X. C is playing the role normally played by Y. So we have when D is equal to 480, C is equal to 380. When D is equal to 800, well, C is equal to 460. So you can think of these as a couple of ordered pairs, 480, comma, 380 is a first-ordered pair. 800, 460 is a second-ordered pair. Again, we're thinking of the distance as the independent variable, the cost as the dependent variable. So we can find the slope then based on that. The slope is going to be given by taking the change in the output, the dependent variable, so I'll take the second one minus the first one, 460 minus 380, divided by the change in the input, 800 minus 480. What do we get here? Well, we get 80 divided by 320, which of course reduces to 1/4. So we have a slope of 1/4, so our function c will be equal to 1/4 times our independent variable d plus some y-intercept b. We need to find that y-intercept. To do that, we can put either of our two values in for d and c. Let's just go ahead and put 480 in for d and 380 in for c. So 480 in for d, 380 in for c. So we'll have 380 equals 1/4 times 480 plus b. And so solving this for b, we have that 380 is equal to 1/4 of 480, which is going to be 120, since 12 times 4 is 48, plus b. Subtracting 120 from both sides, and we get 260 is equal to b. We would have gotten the same thing if we used the other point of 800 and 460 for d and c, respectively. And so our function then becomes c is equal to 1/4 d plus 260. We now have a linear function that gives us the cost dependent upon the miles driven. So if you can tell me how many miles you're going to drive, we can tell you what the cost is going to be. It's going to be based on this function. And so we can do that. Let's put that into action. In part B, we want to use part A to predict the cost of driving 1,500 miles in a month. So if D is equal to 1,500, what's that cost going to be? Well, the cost is going to be f of 1,500, which is 1/4 of 1,500 plus 260. 1,500 divided by 4 is 375, so we have 375 plus 260, which is equal to 635. So it would cost $635 to drive 1,500 miles. In part C, then, we're asked to graph the linear function. We have 1/4 d plus 260. So let's go ahead and do that. And let's not get too technical with it. Let's just kind of give a rough sketch of our graph. What you can see is you have a positive slope of 1/4, and a y-intercept of 0, 260. So it's going to intercept the y, or in this case the c, the cost axis, at 260. And what's it going to do from there? Well, it's going to go up. It's going to go up from there because of this positive slope. Every time I go up 1 unit, I have to go to the right 4. So it's going to have a pretty shallow slope. Now, we know a couple of points on this graph. For example, we know that from up here, 480, 380 is a point on the graph. So if d is equal to 480, then c is equal to 380. We also know another point, let's see, 800, 460. So maybe if we come out here, maybe say this is 800, that means that this right here is 460. So we have a couple other points on here. Let's see, this was 480, 380, and 800, 460. But we have a general idea of what the graph looks like. It's an increasing graph because the slope is positive, and it's a pretty not very steep increasing graph because the slope is pretty small at 1/4, but it does intersect the y-axis at 260, and so that slope again represents the change in the cost given the change in driving. So since the slope is equal to 1/4, what does that represent? That says that, well, it says that an increase of 4 miles driven increases the cost by $1. Remember, our slope can be represented as, well, is equal to the change in the dependent variable divided by the change in the independent variable. So if I change my independent variable d, my distance driven by 4, increase it by 4, I can expect the cost, the change in c, to go up by 1. So every time I increase the miles driven by 4, the cost will go up by $1. In part D, we're asked what the y-intercept represents. Of course, that's this point 0, 260. Always write your intercepts as ordered pairs, 0, 260. Well, this says that we could say it this way, that the fixed costs of driving are $260. In other words, even if, remember we're at 0 right here, even if you don't drive any miles, it's going to cost you $260. So if 0 miles are driven, the cost is $260. We would call that the fixed cost of operating this car. And then part E just asks why a linear function is suitable in this situation. Well, it seems to make sense that you'll have a linear relationship between the miles driven and the cost that is going to amount to for driving. The cost of driving will go up with a linear rate. I mean, the more miles you drive, the more it's going to cost, and that's going to be pretty much a linear relationship. I just noticed that it kind of went off the screen here, so we were talking about part C, the interpretation of the slope. It's an increase of 4 miles driven, increases the cost by $1. So you should be ready to take your 1.2 homework. The password that you're going to need to take that homework is decorous, which means marked by propriety and good taste. Correct. For example, when you do your math, make sure you write your math with a decorous style and not just sloppily on your paper. Good luck in your homework. Please let me know if you have any questions.